All right, let's talk about something I think every developer today knows deep in their bones. It's that feeling you're not just coding anymore, you're vibe coding. You're using AI agents like Copilot or maybe Devin, and you're kind of intuitively guiding them, right? Based on a feeling of what should happen next. It's the new normal. But what do you do when the vibes are just bad?
So just to put a fine point on it, vibe coding is when you're using these AIs to write, debug, and refactor stuff based more on a gut feeling than a super specific command. You're nudging the AI, you're collaborating, and yeah, it feels fast, it feels like the future. But relying on vibes alone, that's where things get frustrating fast.
And that really is the million-dollar question, isn't it? This comes from Ian Butler, the CEO of Bismouth. His team has been doing some really serious research, benchmarking how good these AI agents actually are. They've been digging into the data behind all that frustration, and lucky for us, they've come up with some real answers.
Okay, so let's get into it. We're going to go from that, why isn't this working feeling, to the cold, hard data. And the diagnosis for why our coding vibes get so messed up is, well, it's pretty shocking, actually.
Get ready for this. Bismouth's research benchmarked over 900 reports and found that popular AI agents, Devin, Cursor, the ones we all use, have a true positive bug finding rate of less than 10%. Let that sink in. For every 10 issues they flag as a bug, 9 of them are just noise, false alarms.
And if you think that's bad, it gets worse. Looking at over 100 different repos, Cursor had a 97% false positive rate. 97%. That means you're literally spending almost all your time chasing ghosts in the machine.
And here's a story from Ian Butler that just makes this data painfully real. He said one agent handed them 70 issues for a single task, and every single one of them was wrong. I mean, who has time for that? That's not a bad vibe, that's a nightmare. So this isn't just you getting annoyed. It has a serious real-world impact. It's called alert fatigue. You see so many false alarms that you just start ignoring the tool altogether. You stop trusting it. And that's exactly when the real critical bugs can slip right past you and into production.
All right, so that's the problem. It's a big one. But let's not just stare at it, let's fix it. We're going to pivot to the solution now. And Ian Butler's research gives us our very first prescription for cleaning up those bad vibes. You have to master the rules.
So instead of just saying, hey, find bugs, you need to act more like a really good manager. First, give your agent some intel. Feed it things like the OWASP Top 10, the standard list of web security risks. Second, get specific. Don't say bugs. Say find potential SQL injection vulnerabilities. And third, demand proof. Make the agent write and pass a test to prove its fix actually works. It's all about priming the model for quality.
Okay. Tip number 2. This one tackles another massive problem with AI agents. They have the memory of a goldfish. We're talking about a kind of agent amnesia, especially when they're working in big, complicated codebases.
Here's what's happening under the hood. The agent is scanning your whole project, right? But it hits its context limit, its memory limit, and it starts summarizing files to save space. And when it does that, poof, it loses the logical connections between different parts of the code. Its view gets all scrambled, when what you need is for it to see the full picture, the cause and effect across your entire project.
So, guess what? It's up to you to be the agent's external brain. You can do this by feeding it specific code diffs so it sees what changed. You can also literally tell it, hey, these files are critical, never summarize them. And here's a pro tip from Bismouth's research. Ask the agent to create a component inventory first. Make it map out the classes and variables. It gives the AI a much better mental model to work with.
And now for our third tip. This one, according to all the data, is the most powerful strategy of them all. If you get the choice, you should always be using a specific kind of AI model. They're called thinking models, and they are awesome. These are the models that are actually designed to think step by step. And in the benchmarks, they were way better at finding bugs. Why? Because they do this deep chain of thought analysis. They don't just glance at the surface. They trace the logic. They follow the connections deep into your code. And that's how they uncover those really complex, nested bugs that other models completely miss.
So, great. The answer is just to use thinking models. Problem solved, right? Well, not so fast. There's one last, really important catch we need to talk about.
Are these thinking models the silver bullet we've all been hoping for to get perfect vibe coding? The short answer, unfortunately, is not quite. And here is the catch. Even the very best models available today have high variability. That means you can run the exact same prompt on the exact same code and get a different result each time. They aren't looking at your code the way a human does, holistically. It's more like they're rolling the dice.
Ian Butler explained that when his team ran these agents over and over, the total number of bugs it found might stay the same. Say, it finds 4 bugs. But the actual bugs themselves would be different every single time. The first run might find bugs A and B, the next run finds C and D. It's a huge limitation, and it just goes to show these tools are still very much a work in progress.
So after all that, what's the big takeaway? It seems like the future here isn't just about being a better coder. It's about becoming a better collaborator with your AI partner.
Let's wrap this all up into your 3-part prescription for better vibe coding. 1. Master the rules. Be specific, be demanding, and prime that agent for high-quality results. 2. Control the context. Be the agent's memory so it can reason across your entire code base. And 3. Use thinking models whenever you can to get that deeper analysis. This is how you go from constant frustration to a state of flow.
And that leaves us with one final big question to think about. In this new age of AI, as these tools get more and more powerful but also more weird and complex, maybe the most important skill for a developer isn't just writing code anymore. Maybe it's learning how to manage, guide, and collaborate with an intelligence that is incredibly powerful, deeply flawed, and absolutely here to stay. What do you think?